Hi everybody, welcome to week 2, which is problem set 1 because we started from 0. Alright, so there were 2 really awesome sets of questions that were so cool that I made totally separate videos about them. So the first was about input validation. Several people wanted to know if there is an easy way of checking whether a value is in a given range or whether the thing that the user typed is the right data type. Like they're supposed to type a double. Can you actually check to make sure it's a double without having your thing crash? So I have a whole video about taking a really excellent answer to problem number 3 and making it even better by adding input validation. Then this was, I think this is like the winning question for the entire year. It's hard to know how to start a program, and usually the first time you solve it in the most difficult possible way. And then when you see a more experienced programmer's solution, it seems so easy, and you think, what's wrong with me? Like, why could I not have seen that easy solution? And like, that's what it means to be expert at any skill. You know, like someone who's great at badminton makes it look easy. Jugglers make it look easy. Musicians make it look easy, but it comes through a lot of practice. But, you know, you don't just want unguided practice. So I have a whole video where I'm going to give you the beginning of my advice about the right way to practice the types of thinking skills that are going to make you a better programmer. So the other questions this week, someone says, what's the point of using public void for a method if it's not usable in the main method? So let me talk about that right now. So here's an example solution to number 4 where I'm looping 20 times. I've got a method to return a random integer between 1 and 6. So I'm doing that twice and then displaying the outputs. All right, so if I mouse over this, you see that it says non-static method die roll cannot be referenced from a static context. So what I'd said in the notes about static, not static, is we'll talk about it in a lot more detail during the year, but that a static method is one that can be run without ever creating objects. And a method like this, which is not marked as static, that's called a non-static method, you have to actually create an object in order to run that method, because this is a method that only objects run. So your main method is always marked static because it's the place where your code starts. There is no object created before main runs. Main is the thing that would start your code, and then you could create objects inside main if you wanted to. So that's why main always has to be static. So if you want to just run normal old methods inside main, you'd need to mark those methods as static also in order to indicate that these methods don't need objects to run them. They can just be run directly from within the class. So my guess is that was probably the issue. Another possibility that I sometimes see intro students do is they'll actually declare their method right where they want to run it. So like up here inside main, that's where you declare the method rather than run it. I hope that wasn't the issue, but if it is, it's a really simple fix. You just declare it outside of the place where you want to run it, and then you run it. Someone was wondering about the overflow for double. And by the way, double's not the only thing that can overflow. Int can also. Really any primitive type could. Well, I mean, not Boolean. Anyway, so any primitive numeric type could. So they said, like, why is it that if you're at the maximum value and you add 1, it becomes the smallest value? That's a more complicated question, or it's a longer question than I can answer right now, but that's something we're going to talk about in week 1. And it's kind of cool to get under the hood and figure out why is that happening. Does @param mean anything? Yes, param is short for parameter, and that is the notation for Javadoc style comments that's saying that you're just about to include documentation for what the parameter to your method actually represents. So it's something that you put in a comment as a way of automatically defining that line as talking about the meaning of your inputs. Someone wants to know does the code become more complex in the real world for wind chill because there's other factors? Well, it's not the code that would be more complex. It would be the mathematical model that our code is implementing. So I gave you this equation, which is a mathematical model. But like all mathematical models, it's only valid for a particular natural domain of input numbers. So if you wanted to make a more accurate mathematical model, or if you wanted to make a mathematical model that applied beyond that domain, you would need to have more complex mathematics. Maybe you would have a piecewise defined function. Maybe you'd have something else. And if you were going to implement that in code, then yes, you would have to have more code to reflect that extra mathematics. But really, it's the math that's going to become more complicated, not primarily the code. Someone said, while working on the dice problem, they were curious as to why math.random returns a random number in the range 0 to 1, but not including 1. Like, why is that a thing? So I think there's probably other reasons, but this is the first one that came to my mind. It makes dealing with lists and arrays particularly clean. So let's pretend you have an array like this. This array has 11 elements, but you'll notice that the last location number is 10 because you start at 0. So if this is called list and I say list.size isn't going to return 10, the last location. It's going to return 11. It returns how many things there are. So what if I wanted to get a random value from the list? The way that I would do it is I generate a random location number. Okay, well, so how am I going to do that? So I'll have to use math.random, but then I'm going to scale this interval up so that instead of being from 0 to 1, it's 0 to something else. Okay, so here's what's nice. If I want to get a random value from an array whose size is 11, I can put 11 right here. Because math.random is never going to be equal to 1. So if you multiply it by 11, it's never going to be equal to 11. And that means that you're never going to be off the end of your array. So if your array is length 11 and you put 11 here as your multiplier, the largest int you're going to get is 10 and the smallest int you're going to get is 0. So it's perfectly set up to give you a random number exactly in the range that you need. If math.random actually did return in the interval from 0 to 1, including 1, then you'd have to multiply by list.size minus 1, which seems less clean. It's a little more awkward. All right, so that's it for this video. But if you're interested in those other two really excellent questions, where were they? If you're interested in the input validation question or the how do you think about programming question, come back for the other videos because I hope that I'll say some useful stuff.